So we're going to test the series for convergence or divergence. So what I would do with this one is a limit comparison test. With the limit comparison test, we take the limit as n approaches infinity of a sub n over b sub n. So what is a sub n and what is b sub n? A sub n is whatever we have originally. So our a sub n is going to be the tangent of 1 over n, whereas our b sub n is going to be something that we choose strategically, knowing that this is what we're going to do. So what I would choose is 1 over n, because 1 over n is what we have in there. So we have 1 over n, and then why are we doing the limit comparison test? How does that work? Well, that works by looking at whatever happens to the series with b sub n in it, and then the series with a sub n in it. By the way, mosquitoes aren't conscious, so I can kill them. A sub n is tangent of 1 over n. Tangent of 1 over n. And whatever happens to this is going to happen to this. If this diverges, the one with b sub n, then this is going to diverge, as long as this gives us a positive, as long as it's a positive constant. So we choose an a sub n that's always positive. I mean, our a sub n has to be always positive if we're going to do this limit comparison test. Our b sub n is also always going to be positive, and we choose it to be something that's always positive. And yes, the harmonic series is always positive no matter what you plug in, because we're plugging in positive integers into there. So we know this diverges. This is also going to diverge, as long as when we do the limit comparison test with this, that we know it diverges, this gives us a positive constant. So let's see if that gives us a positive constant. Limit as n approaches infinity. This is tangent of 1 over n. This is our a sub n. Our b sub n is 1 over n. So notice that we have 1 over n and we have 1 over n. Two terms which are the same, 1 over n and 1 over n. This is something that we tend to do. There's been a bunch of problems in which I've done this before, that we have 1 over n and 1 over n there, so we switch the limit, because notice that as n approaches infinity, this goes to 0 and this goes to 0. So we're going to switch this with a single term. This is t now, and this is t, and now t goes to 0. T goes to 0. So now that we have this, we can move on. Limit as t approaches 0. What happens? What actually happens? Well, let's break it down. Sine of t over cosine of t is what we have there, times 1 over t. So this is what we actually have going on. And we can switch it. We can have this over here and this right there, cosine of t. Now this makes everything just far more clear. If we were to put 0 in here, what's going to happen? What's going to happen? Well, cosine of 0 is 1. So this is 1 over 1. We applied this already. We applied this. That was 0 over 0, which is an indeterminate product. It's just like when you have infinity over infinity, so we can use L'Hopital's rule on that, actually. So we take the derivative of the top and derivative of the bottom. That's cosine of t is that, and this is 1. And it's still going to 0. We're still plugging in 0 when we do L'Hopital's rule. We're still taking a limit. So cosine of 0, what's that? That's 1. So that gives us 1. 1 over 1 times 1 is all just 1. So yes, after doing this, we get a positive constant, which is 1. That means that whatever applies to this series with b sub n in it also applies to the series that has a sub n in it. So this is the limit comparison test. We know that this diverges, and that also applies to this one, so therefore our original series diverges.